initial rate, and then we have an instantaneous and average rate. Okay, so after we discuss that rate can be average, instantaneous, and initial, okay, we discuss the rate expression in terms of the changes of the concentration of the reactant and product. So that if let's say we have a reaction A plus 2B produce C, the rate expression will be rate equal to negative delta concentration A over delta T equal to negative 1 over coefficient delta concentration of B over delta T equal to what, class? Positive delta concentration of C over delta T. Okay, after this, okay, we discuss on rate expression in terms of the changes, and then we discuss on the rate law. Okay, in the rate law, we discuss that, okay, if you have two reactant A and also B, you should be able to determine what is the order of all reactants. Okay, and then after you got the value of the order, then you can determine the rate constant value. Okay, and then if let's say you know what is the order of all reactants, okay, you also have calculate what is the rate constant. Okay, and you are given two new equations of A and B. You can use the data, you can predict what is the new rate without doing that experiment. Okay, and then after the rate law, okay, we discuss on the integrated equation. Okay, in the integrated equation, okay, it is divided to three orders that we covered in our syllabus. Okay, zero order is when the integrated rate equation is, what is the integrated equation for zero order at Ali Ubaidah?
K um concentration of uh, um K concentration of A, right?
What? It is A naught minus
Oh, minus A T.
equal to
Um, KT, right?
it is equal to K T.
T.
Okay, and then rate constant unit for the zero order reaction will be the same as the rate unit, which is concentration per time. Okay, if we have a first order reaction, okay, the integrated rate law will be what, Fatihah? Nur Fatihah Adawiyah?
Ln A naught over AT equals to KT.
Okay, and then the rate constant will be, the unit for the rate constant is the time -1. And then if we have a second order reaction, okay, the integrated rate law will be 1 over AT minus 1 over A naught equal to KT, and the rate constant unit will be concentration -1 time -1. Okay, so from this integrated rate law, we also rearrange the equation, all these three integrated rate equation, to achieve a linear equation. Okay, it is used to achieve linear equation y equal to mx plus c to determine the order of a reaction by using graphical method. Okay, so from this graphical method, we know that for the zero order reaction, if we want to get a linear graph, we have to plot the graph of the concentration versus time. Okay, then we'll get a linear graph. As for the first order reaction, if you want to get a linear graph, we have to plot a graph of ln concentration versus time. Okay, then we'll get a linear graph. As for the second order reaction, if you want to get a linear graph, then we have to plot a graph of 1 over concentration versus time. Then we'll get a linear graph. Okay, this is a graphical method to determine the order. So after this, then we look at three factors that affect the rate of reaction. We discuss in details factors of concentration. Okay, so concentration, we talk about the collision theory, in which in order for the reaction to occur, the particles needs to collide. Then after that, we discuss on the effect of the temperature. Okay, temperature give two effect. The first one is to the frequency, second is to the energy of the collision. Okay, and then third, we discuss the catalyst factor. Okay, we know that catalysts increase the rate of the reaction or speed up the rate of the reaction without being consumed. Okay, by providing alternative pathway. There are two types of catalysts, homogeneous and heterogeneous. Okay, and then in these factors, we also discuss that there are two types of collision. Okay, collision that leads to the product, okay, is what we call as the effective collision. Okay, it has two requirements. The first one is the enough energy or achieve EA. Okay, second requirement for the effective collision is correct molecular orientation. Okay, and the second type of collision is ineffective. Okay, of course, that ineffective means that no product form. Okay. Then after we discuss these three factors, concentration, temperature, and catalyst, okay, finally, okay, today we discuss on the reaction mechanism. Okay, this is the last thing that we discuss. Okay, in the reaction mechanism, firstly, you have to be able to identify, you have to be able to define all. Okay, you have to be able to know what is the elementary step. You have to know what is the intermediate. Okay, you have to be able to write the overall equation and so on. Okay, and then after that, you need to be able to validate the proposed mechanism. Okay, you have to check the proposed mechanism whether it is valid or not. Okay, okay, that's all that we learn in this chapter for kinetic. Sikit je kan kita belajar ni kalau tengok. One page je. Two page kalau exam pad lah. Okay. No question? Okay, let's move to the chapter 5. I want you to look at your textbook, chapter 5, atomic structure. What page? Page berapa? Can someone share with us? What page that we should refer to? Kasdina, what page Kasdina? Atomic structure in the textbook?
Tengah cari.
For 05 ke madam?